Today we are finally going to get into derivatives of logarithms, and later this section we'll get into integrals of logarithms. But by the end of today you're going to be able to derive several different types of logarithmic functions. So, first of all, I'm going to give you some formulas at the top. Technically, you should memorize these. ln of x, this is the one you'll see most often. This one you see pretty often. This one is a little more rare. Generically, they can all be thought of as 1 over x times the ln of the base, and which makes sense on this one and this one. On our first one, it'd be 1 over x, ln, and e is our base. Well, ln of e is 1, which is why it's 1 over x. So there's a bit of an explanation for that. So let's try some. Well, we've got ln of x squared plus 1, which means y prime is going to be 1 over x squared plus 1, but we need the chain rule because x squared plus 1's derivative is not 1. We multiply by 2x, so our derivative is really 2x over x squared plus 1. 2x is the derivative of our x squared plus 1. Don't forget to multiply by the derivative of the inside. So we've got ln of sine of x, which gives us 1 over sine of x. Multiply by sine of x is derivative, which is cosine of x. We end up with cosine over sine, which is the same thing as cotangent. Chain rule, we've got something to the 1/2 power. I'm going to rewrite this first as ln of x to the 1/2. All to derive, we take 1/2 ln of x to the negative 1/2 times the derivative of ln of x. I'm going to simplify this a little bit. Y prime is going to equal 1 over 2x radical ln of x. When you move everything so that their exponents are positive. Or, interesting enough, we're going to have to not only, a couple approaches here, we could put 1 over that whole fraction of x plus 1 over radical x minus 2, or maybe we should do some algebra first before we find the derivative. What if we did this? Further, which I could then rewrite as now deriving is not going to be as bad. We're going to get 1 over x plus 1 times 1, because x plus 1's derivative is 1, minus 1/2 times 1 over x minus 2. Also times 1 because x minus 2's derivative is 1. Get 1 over x plus 1 minus 1 over 2 times x minus 2. Now, so this one says find the absolute minimum value of f of x equals x squared ln of x. Well, how do we go about finding minimum? First derivative. So, first thing we need to get is the first derivative. And it's going to involve the product rule. First times the derivative of the second plus the second times the derivative of the first. So, if I rewrite this, I get x plus 2x ln of x, and to find the maxes or mins, I need to set this equal to 0. So, when I set this equal to 0, I can factor out an x, and I find out that x equals 0, 2 ln of x equals negative 1, ln of x equals negative 1/2, solve for x equals e to the negative 1/2, or 1 over radical e. need to figure out which one is our minimum. We may not have to do much because our maximum, minimum, yes. Because x equals 0 is an extraneous root. ln of x's have to be greater than 0 if you remember that their graphs look like this. They never cross the y-axis. So, our answer is 1 over radical e. Now, these next two examples, same rules from the front, but now we have a log other than a natural log. So, the derivative of log base 10 of 2 plus sine x is going to be 1 over 2 plus sine of x times the ln of 10. Then I have to multiply by 2 plus sine of x's derivative, which is cosine of x, so our derivative is cosine of x over 2 plus sine of x ln of 10. Try this second one on your own. We will talk about it in class tomorrow. See what you get. Second example, d over dx of a of x, and this is not one that was on the front, so, scratch that, I'm trying to highlight. We need to memorize this. So, derivative of y equals 2 to the x is going to be 2 to the x ln of 2. That's pretty easy because x's derivative is 1. If x is anything other than 1, you're going to have to multiply by its derivative. So, derivative of y equals 10 to the x squared. Y equals 10 to the x squared times the ln of 10 times 2x. And we should simplify that probably to be 2x times 10 to the x squared ln of 10. Finally, last thing we're going to talk about today is logarithmic differentiation. And it's not tricky if you are careful to follow the steps. And it does involve implicit differentiation a little bit. So, first thing it says is take logarithms of both sides. So I'm going to make this ln of y equals ln of 3x plus 1 to the 4th minus 2x squared minus 1 to the 5th. Now, before we jump into the deriving, I'm going to split this logarithm up a little bit. Hopefully you'll follow me if I do this all in one step. We've got 4 ln of 3x plus 1 plus 5 ln of 2x squared minus 1. It's addition because our binomials were multiplied, and then those powers can be moved up front. So now we can derive. But keep in mind that we are deriving in terms of x. So the ln of y is 1 over y dy dx equals derivative of 4 ln of 3x plus 1 is 4 over 3x plus 1. Actually, let me show that. Keep the 4. We've got 1 over 3x plus 1 times 3 as the derivative of that first logarithm, plus 5 times 1 over 2x squared minus 1 times 4x. So if I rewrite this a little bit, 1 over y dy dx equals 12 over 3x plus 1 plus 20x over 2x squared minus 1. We're trying to find the derivative, so we need dy dx by itself on this left side. So I'm going to multiply both sides by y. So I get y times 12 over 3x plus 1 plus 20x over 2x squared minus 1. And don't leave a y in your answer because we're deriving, we want the derivative in terms of x. We're not entirely in terms of x as long as that y is there. So dy dx is going to equal, we know what y equals. Y equals this. So 3x plus 1 to the 4th, 2x squared minus 1 to the 5th, all multiplied by 12 over 3x plus 1 plus 20x over 2x squared minus 1. Look over these, finish that one problem. We can go over the answer tomorrow and come with questions for class.